Overview of security methods. Solutions to protect against attacks are classified as cryptographic techniques or authentication techniques. Cryptographic techniques. What is cryptography? Cryptography is the process of transforming a piece of information or message shared by two parties into some sort of code, that is, scramble the message before transmission. Then the message must be decoded at the receiver for further processing. So the encryption terminology means it's the process of taking the plain text like message, scramble it into an unreadable format called ciphertext. Let us take a message M and a secret key K. So to perform encryption, we are using the XOR operation. So the encryption can be done by M XOR K. So to decrypt the message, the one must know the secret key. So the decryption operation can be performed this way. The encrypted message once again XORed with the key to get back the original message. Overview of encryption points in the communication network. There are two types of encryption devices installed in communication network: end-to-end encryption and link encryption. We can see in this particular diagram, sender with the secret key scrambles the message. Receiver with the key will be able to decrypt the message. So this encryption is also called as end-to-end encryption, whereas this encrypted message which travels through an unsecured channel. So links encryption can be provided which will secure all the traffic passing over the link. The two types of encryption techniques are secret key encryption, where the same key is used for encrypting as well as decrypting. Public key encryption, which uses different key for encryption and decryption. Second solution to protect computer communication networks from attacks is the authentication technique. Encryption techniques are used to ensure the message confidentiality, whereas authentication techniques verify the authenticity of the message and the sender of the message. That is, it ensures that the message is genuine and not altered, and also the message is from the original sender. It protects user against data falsification and also ensures data integrity, that is, the data is not altered. Authentication techniques are categorized as authentication with message digest, authentication with digital signatures. These methods do not necessarily use keys. Key encryption protocols, also known as symmetric encryption or single key encryption. It consists of an encryption algorithm, a secret key, and a decryption algorithm. Two protocols are mainly focused in this chapter: Data Encryption Standard (DES), Advanced Encryption Standard (AES). A shared secret key is assigned at the transmitter and at the receiver points. So the algorithm produces different key at any time for a specific transmission. The security of the encryption depends on the secrecy of the key, not the encryption algorithm. That means the algorithm need not be kept secret, whereas the key has to be kept secret. Data encryption standard. It's a symmetric key algorithm for the encryption of digital data. Symmetric key algorithm means the same key is used for both encryption and decryption, also called as secret key encryption. Although DES makes use of key length of 56 bits, it is considered as insecure for application, but it has been highly influential in the advancement of cryptography. Here, plain text messages are converted into 64-bit blocks, each encrypted using a key. The key length is 64 bits, but it contains only 56 usable bits. So the size of the key is going to be 56 bits. The last bit of each 8 byte in the key is a parity bit for the corresponding byte. DES consists of 16 identical rounds of an operation. DES algorithm. First step is initialization. All 64 bits of a incoming message and all 56 bits of the secret key are first separately permuted, that is shuffled. Each incoming 64 bit is broken into 32-bit halves denoted as left half and right half. The 56-bit key also broken into 28-bit halves, and each half is rotated 1 or 2-bit positions depending on the round. All 56 bits of the key are once again permuted, producing version Ki of the key on round I. And next step is assigning the right half to the left half and computing the right half as left half XORing with the value of the round function, which takes the right half and the version Ki version of the key. Next, the resultant 64 bits of the message are once again permuted, and this output is given as an input to the next round. So in each round, the step 5 and step 6 will be repeated. The heart of the DES algorithm is the DES function denoted as F. The operation of F at any round I of DES is as follows. So out of 56 bits of key, the function F chooses 48 bits. The 32-bit is expanded from 32 bits to 48 bits so that it can be combined with 48-bit of the key. How this expansion is carried out? This expansion is carried out by breaking into 8 4-bit chunks. So we have 32-bit which is broken into 8 4-bit chunks, and this chunk is expanded by copying the leftmost bit and rightmost bit from the left and right adjacent chunks respectively. The function F also partitions the key bits, that is 48 bits of key, into 8 6-bit chunks. Now the data bits as well as the key bits are in 6-bit chunk format. Now the corresponding 8 chunks of Ri and 8 chunks of Ki are combined. So this is what the F function does. It performs the XOR operation on the right half of the data bit and the keys. The block diagram of DES algorithm, we have a 64-bit plain text and 56-bit key. Both are permuted, and plain text is divided into 2 halves, left half and right half, each 32-bit. And the secret key also divided into 2 halves, 28 bits, and the bits of the secret key are rotated this number of bits to be rotated is depending on the round. Now the right half is assigned to left half. So we can see here the right half is assigned to the left half, and the new right half is calculated as the left half. So the left half, and it is XORed with the result of the ds function. So the ds function, what it does is it computes the right half as right half XORed with the key bit. Now the key 48-bit key is considered, and the 32-bit array is also expanded to 48-bit, and the new array is calculated, and the output of this ds function is XORed with the left part, and we get the result in the form of 32 bits. So now 64 bits are again permuted, and the output of the permutation again divided into left half and right half, and it is fed to the next round. So usually your DS algorithm will have 16 rounds, and after 16 rounds you get a ciphertext of 64-bit. At the receiver side, the same steps and the keys are used to reverse the encryption. The 56-bit key is not sufficient to provide full security. So instead of DES, nowadays triple DES is used. It provides better security because it uses 3 keys of total 168 bit in length. Advanced Encryption Standard, also known as AES, the most common and widely used symmetric block cipher algorithm in worldwide. This algorithm has an own particular structure to encrypt and decrypt sensitive data and is applied in hardware and software all over the world. It is extremely difficult to hackers to get the real data when encrypting by AES algorithm. Some of the applications which use AES are Wi-Fi. It can be used as a part of WPA2. Mobile apps such as WhatsApp and LastPass applications, they use AES algorithm for encryption. It provides better security than DES algorithm. The AES algorithm, it supports 128-bit symmetric block messages and uses 128 or 192 or 256-bit keys. The number of rounds in AES is variable from 10 to 14 rounds depending on the key and the block sizes. Input is a single block here of 128-bit size, which is divided into 16 bytes and fed to round 1 after an initialization stage. The initialization stage is also called as round 0. Substitution units perform a byte by byte substitutions. Ciphers in the form of rows and columns move through the permutation stage to shift rows to mix columns. All 16 blocks of cipher are XORed with 16 bytes of round key. This is the block diagram of AES protocol. The input is 128-bit long. The input is divided into 16 bytes. So it is labeled here as M0 to M15. The input goes through a initialization stage where the input is XORed with the cipher key. Here the cipher key is also 128-bit long. So the input is fed to the substitution box, or also called as S box. So S box converts every byte into a different value. AES defines a table of 256 values for the substitution. So each byte is used as an index into the table and replace the byte value with the value from the substitution table. Suppose the input is having a byte value is 19. This value is looked in the substitution table and the new value will be replaced with the value, and the output of the substitution block is given to the permutation block. So in the permutation block, each row is rotated to right by certain number of bytes. So here each row is going, so this row might be rotated by 1 byte, or this row might be rotated by 2 bytes, this row will be rotated by 3 bytes, and so on. Next, the output of this is fed to the mixed column. In the mixed column, each column is processed to produce a new column. After the mixed column, the XOR operation is performed with the round key. So we can see this round key labeled K1 up to K15. So how these round keys are generated? So there will be 11 round keys. So 10 round keys are for 10 rounds, and the one round key that is the cipher key itself is called as round 0 key, which is used in the initialization stage. So this round key is generated by this cipher key. So from this 128 bits, 10 round keys are generated, including round 0 key, which is the original cipher key itself. So after XORing the round key value with the output of mixed column, the output of the round 1 will be fed to the round 2, and so on. So from round 1 to round 9, the stages are seen. You have a substitution block, permutation, that is shifting of the rows, mixed columns, and so on. But at the round 10, there is going to be only substitution stage and permutation. There is no mixed column. So this is the explanation of your AES algorithm. AES decryption algorithm. Decryption involves reversing all the steps taken in the encryption using inverse function. So you have inversing of substitution of the bytes, inversing shift rows or the permutation, inversing the mixed columns. XOR round key does not need an inverse. Rest all steps requires inversing. So this is the order of operation in decryption. So first, initial decryption round. So XOR with the round key, inverse the shift rows, inverse the sub bytes. Next, perform 9 full decryption rounds. XOR with the round key, inverse mixed columns, inverse shift rows, inverse sub bytes. So you can see here the missing of inverse mixed columns, because as you remember in the AES encryption algorithm, so the last round do not have the mixed column. Now whole process is inverse, so we are starting from the last round, so with the inverse operation, so you will not have the inverse mixed columns. So you have for the other steps round key, inversing mixed columns, shift rows and sub bytes. So all the steps in the reverse order. Next, perform the final XOR with the round key.